Welcome back. Today we're doing problem 238, product of array except self. It's a good problem. I've seen this. A friend of mine actually got this asked to him in an Amazon interview. So it's a relevant problem. It's a pretty good one. Given an integer array nums, return an answer array such that answer at index I is equal to the product of all the elements of nums, except for nums at I. You must write this algorithm that runs in O of n time and doesn't use the division operation. So first example given 1, 2, 3, 4. The output is 24, 12, 8, and 6. We have 24 because everything except for this one multiplied together is 24. 2 times 3 times 4 is 24. It's 12 because ignoring this 2, 1 times 3 times 4 is 12. 8 because without this 3, 1 times 2 times 4 is 8. 6 because without this 4, 1 times 2 times 3 is 6. Second example is pretty straightforward as well. And I actually just did this problem to make sure that it was right. But the way that we're going to do this, right? Let's talk about first how do we do this in a way. Let's ignore this constraint. If we can use the division operation, the problem becomes pretty straightforward. Let's say that we're given this list. How do I know what the value is? Well, what I'm going to do, what you can do here is just multiply all the numbers together, and then you get a total. What is the answer at index I, ignoring the element at index I? Well, you can just divide by the value, right? 24 divided by 1, 24. 24 divided by 12, 2, is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. So that way you disclude your self from the total value. Really easy, really straightforward. So now let's think about how can we do this without division? We can do this without division by approaching it in almost like a dynamic programming approach. What we can do is the general idea that you're trying to solve and ask is that how do I know how to multiply all the numbers to my left and to my right so that I ignore myself? Well, one way you can do it, right, is let's say I want to figure out what the answer is when I ignore this 2. Well, I have to know all of the values to my left, all the values to my right. I could write a loop that goes through everything to my left, multiplies them all together, and then another loop that multiplies everything to my right, multiplies them all together, and then multiply those two things together. The problem with that is that you have to do O of n every single time for every value. You get a really long algorithm that is not optimal. So the way we're going to approach this is let's just calculate those values before we do anything. And what I mean by those values is left dynamic programming array, right? Left list is going to keep track of all the elements to the left of index I. Right is going to keep track of all of the elements, the product of all of them, to the right of index I. The reason that we fill them up both with 1s first is because the elements to the left of this 1, there's nothing. And so if we put a 0 to represent the product of everything to the left, it's actually going to cause problems for us in the future because 0 multiplied by anything is a 0. So that's why we have a 1 here. What we're going to do, right, is left at the next value we're going to put into left is the nums at index I times what we already have at left. So when index I is 0, it's 1. 1 times 1 is 1. When it's we're trying to do what is to the left of 3, 2 times what we just calculated is 2, right? 2 times 1 is 2. When we're trying to calculate everything to the left of 4, 3 times the most previously calculated item in left is 6. To the right, what we're going to do is everything to the right of 4 is 1. To the right of 3 is 4 times what we just calculated in right, which is 4 times 1, so it's 4. To the right of 2 is 3 times what we just calculated in right, which is 3 times 4, it's 12. To the right of 1 is 2 times everything we just calculated in right, which is 24. Now, the idea here is that once we have this calculated, our answer is going to be the multiplication between the left and the right of it's the left and the right multiplied together, but you have to be careful because in you're going left to right for the left list, but right to left for the right list. So 1 times 24 is 24, 1 times 12 is 12, 2 times 4 is 8, 6 times 1 is 6, and this is your answer. So let's go ahead and code this up. First thing we're going to do is create that left list, create a right list, and I'm just going to say n is equal to the length of nums. And the first thing after this is we're going to populate that left list, right? So for I in range n, product equals nums at I times our most recently calculated value for the left, right? Which is at the end of our left list. Now what we're going to do is append that product into our left list. Here, we're done. Now we populate our right list. Very similar, but slightly different. I'm going to say j is equal to n minus 1, so we can get the last value of our nums list, while j is greater than 0. So go backwards from nums. Our product is going to be nums at j times right at index 0, right? The thing at the very left. Now what we do is we do right dot insert at index 0 our product. This is a little bit different from what we just discussed. The reason I'm doing it this way, where I'm inserting at the front of the right list, right, is because that way when I loop through both left and right to calculate the answer, which is going to just be left at index I times right at index I. That way they correspond at the same indices, and I don't have to do left at index I, which is going left to right, and then right at index the end. See how they kind of have to crisscross? The way I have it inserting into the right list now, this actually goes from left to right in the opposite order such that I can just go straight down and multiply them. Don't have to worry about some indices. So now, right, what we're going to do is we don't have to make a new list. Let's just loop up to n. And what we can do is just use the nums list they gave us. And then at the end, we can return nums. That should work, hopefully. Great. So, this problem, what's the runtime? it's O of 3 times n, which is just O of n. One loop here, making the left, one loop here, making the right, one more loop to fill up our answer. In terms of memory, we're using O of n as well. We're keeping track of the left and the right product lists. So this follows the constraint that they gave us and does it in an efficient way. There might be a way to do this without using extra memory. Honestly, maybe. I can't think of one. This is just how I did it. So yeah, thanks.